Welcome students. In this lecture we are going to evaluate the triple integral value given that the limit varies x from 0 to 1, y for 0 to 2 and z for 0 to 3 of the function x plus y plus z. Okay, our initiative is to determine this integral value. Actually, we have to integrate these things by reverse manner. Okay, I will rewrite this sum 0 to 1, 0 to 2 and 0 to 3 the function x plus y plus z. In this manner is dz dy dx. What it means? Actually, this integral value can be found by this thing first, right? What it means, 0 to 3 is the limit of z. Now I am going to integrate this function with respect to first z and get the value, and then proceed the same business for dy and dx. Now this integral limits I will write the same. Now I will integrate x plus y plus z with respect to z. Okay, actually it has three terms. We are going to integrate this by at a single step. Okay, since x is independent of z, therefore if you integrate this you will introduce z. Y is also independent of z, therefore we need to add yz. Since z is a function of z, therefore use this formula z dz equal to z square by 2. Okay, straight away I will write z square divided by 2 with the limit 0 to 3. Here 0 is the lower limit and 3 is the upper limit. I will write these things as same and substitute the limits of y instead of z in this expression. Okay, here x I have to substitute the upper limit first. X into 3 z, x into 3 plus y into 3, its y value, z square 3 square divided by 2 minus the lower limit, x into 0 which is 0 plus y into 0 which is also 0, and z square 0 square is 0. First I will simplify these things, then it becomes 3x plus 3y plus 9 square divided by 2. It's again another function of this type, but instead of z we have only a constant. Again do the same integration for this with respect to y. Okay, therefore I will write 0 to 1. I will integrate this thing with respect to y and substitute the limit of 0 to 2. 3x is independent of y, therefore we need to introduce y in this term. 3xy plus 3, actually y is dependent of this thing y, therefore 3y into dy means y square divided by 2 plus 9 divided by 2 is independent of y, therefore we need to add this. Okay, substitute the limits 0 to 1. Substitute the upper limit. Instead of y, you will get 3x into 2 plus 3 2 square divided by 2 plus 9 by 2 into 2 minus the lower limit, which is 0. Wherever y presents, you need to put there as a 0. 3x into 0 means it is 0 plus 3y square, which is 0 plus 9 by 2 y, which is also 0. Just simplify the above, you will get 3x into 2, which will be 6x plus 3 2 square will be 4, you will get 2, 3 into 2 6 plus 9 into dz. I will write the above step as the following: 6x plus 15, sorry, it is not actually dz, actually I made mistake here. I already do my integration with respect to z, therefore here all the things were with respect to x. I was mistakenly write that thing. I will modify dx, no issues. First step itself, it will be x alone. Okay, it could be dx. Again integrate this with respect to x, you will get 6x square divided by 2 plus 15x 0 to 1. Okay, what will you get? 6 into 1 square divided by 2, its upper limit, plus 15 into 1 minus 0 plus 0. 6 by 2 plus 15, it will be 3 plus 15, which is 80. It's our total integral value. Actually integration means it is finding volume, surface, like that. I will once again recollected what we done in the above. We have to integrate this, evaluate this thing first. It is the limit 0 to 3 is the limit of z, therefore we need to integrate in the reverse manner dz dy dx. Okay, if we integrate this with respect to z, x is independent of z, therefore introduce z here, and y is also independent of z, therefore introduce z here. What it means, if it is integral, I will write rough work, integral c into dx means c into integral dx, then here c is the constant, c into x. In this manner integral x dz means, these are the rough work, don't get confusion. It can be written as x dz, since x dz could be z, therefore I will write integral x dz straight away, x dz. If it is a term is independent of a integrator means dz dy dx, all these things are called integrator. This function is called integrand. Once you integrate a function with respect to one variable, straight away you need to substitute the upper and lower limits in the immediate next step. After only you integrate with respect to another variable. Again integrate with respect to y. 3x is independent of y, therefore introduce y here. 3y, actually it is in the form of integral z, therefore it integral 3x dy can, 3y dy can be written as integral 3 into y dy, 3y square divided by 2, that's it. Again substitute an upper and lower value and simplify, and finally integrate with respect to x and substitute the upper and lower limit, you will get the final answer. That's it. Thank you.